Hello everyone, welcome back to Diksha Vedantu Foundation channel. Today is the day 70 of your 99% in 99 days, and today we are going to discuss the sample paper 4, and in this lecture we are going to discuss the physics. The chemistry and biology part is already discussed. You can check that out in our channel, and if you have not yet subscribed to our channel to get more update for your final preparation, class 10th preparation, don't forget to subscribe to our channel and share it with your friends so that more and more students get help from our channel. Right now, without any delay, let's start with the question paper analysis. So as you can see in this question paper, we have 1 marker question, 3 of them, that is 2 MCQ and 1 assertion and reason based question. Then we have 2 number of question, 2 marker question is 2, so total 4 marks. Again 3 mark question is 3, so total 9 marks, and 1 5 marker, 1 4 marker, so total marks as usual allotted to physics is 25. So 25 marks questions we are going to answer in today's lecture, right? So if you follow this complete lecture, 25 marks will be in your pocket, right? So let's start with 1 mark question. Question number 13. When an object was kept at position X in front of a concave mirror, an enlarged and virtual image was formed. Which among the following identifies X correctly? Okay, so object was kept at a position X in front of a concave mirror. Okay, the mirror is concave mirror, it's a mirror and it's concave. An enlarged and virtual image, so enlarged and virtual image was formed. So concave mirror forms enlarged and virtual image only when it is placed at a distance between the optical center of the mirror and the focal length. So if it is the optical center, even though my line is not super straight, so now this is okay. So this is optical center, say O, this is focus, say F. So if you keep the object between F and O, then only you will get an virtual and erect object. You get somewhere here, sorry, virtual and erect object. So anywhere between the center of, let's see the answer. So it should be between optical center and or center of the mirror. Generally we say center of the mirror or pole of the mirror, and focal length, optical center term is used for lens. Okay, so anywhere between the center of curvature and principal focus, no, incorrect. So center of curvature is somewhere here, 2f, at a distance 2f. So center of curvature, say center. So center of curvature is denoted by the symbol C. So now anywhere between the pole and the principal focus, yes, anywhere between the pole of the mirror, that is center of the mirror, pole of the mirror and the principal focus, if you keep the object, then it will definitely produce a virtual and erect object, enlarged object. So that is correct option. Let's see the option C, exactly at the center of curvature, exactly at the principal focus. Both are not correct. Okay, if you keep at exactly at center of curvature, you will get exactly same size but in the opposite orientation. So basically it's an what should I say, it is an magnification will be 1 and it is a real image. If you put it on the focus, the image forms at infinity. So basically that is also real image, but it is highly enlarged and inverted, so that is also not possible. So only when it is placed between the optical center and the principal focus, there you get the virtual and enlarged image. Now let's move on to the next question. Question number 14. The face of the moon that is visible to us is called the near side, and the face of the moon which is invisible to us is called the far side. What color would the sky appear to an astronaut standing on the far side of the moon, and why? Blue, as the moon atmosphere scatters the sunlight like earth. White, as moon surface reflects all the light falls on us. Black, as there is no atmosphere on the moon to scatter sunlight. Black, as sunlight does not fall on the far side of the moon. Okay, so basically even if it is a far side of the moon, okay, the sunlight do falls and it is like a night sky. okay. So it's like a night sky and everything will be black because there is no atmosphere on the moon to scatter the sunlight, okay. So because of the scattering only we see the color, right, and if there is no scattering happens, then we will see that it will be black, right. Far side and near side depends only from perspective of earth. So for example, when there is a daytime on earth, okay, the moon's far side, the sun rays fall on the dark side of the moon, right. So it is immaterial that which side is involved in the far side or dark side, okay. There are some region on moon where sunlight is very less, but there is they also have sunlight. Because of there is no atmosphere, you do not see any scattering of sunlight, okay. So that is why it will appear black, okay. Next question. Assertion: iron filings scattered around a straight current carrying conductor in a plane perpendicular to the length of the conductor arrange themselves in the concentric circle. So what is the reason? Reason is magnetic field has both magnitude and direction, okay. So first is that when you put iron filings along the length of the conductor arrange themselves in the concentric circles, yes. So if you put like this, we have seen this during our class discussion that they forms concentric circles, right, if you tap it. Now is it anything to do with magnitude? Okay, as you are going away the field lines are weaker, but is it there in the region anywhere? So they have said that you arrange themselves in concentric circles, okay, and magnetic field both has both magnitude and direction, yes, that is also correct. Reason is correct, assertion is correct, but there is no direct relationship between reason and assertion, okay. So magnetic field is a vector quantity. If you have studied about vector, scalars and vector in your class 9th physics chapter, okay, there was briefly discussed about scalars and vectors, right. So magnetic field is a vector quantity. It has magnitude as well as direction. So obviously reason is correct, but there is no direct relationship between assertion and reason. So we can say that both A and R are true, but R is not the correct explanation of A. So option B is the correct answer in this case. Now next question, next part is section B, 2 marker question. Let's see that. So if you see this diagram, there is a diagram they have given that there is a person using a mirror to check the what is below the car, right. So this type of mirrors are used to check if you are hiding anyone or any bomb or any weapon inside your below the car, or someone has fitted anything, any suspicious things inside your car, so that without going down the car you can check it using this kind of mirror. And this is very common when you visit sensitive places or very high-end hotels, 5-star hotels. They will definitely check the whatever is inside your car, right. Now such mirrors are mirrors that are used to look for hidden objects underneath the cars as shown. The hidden objects can easily be spotted as the mirror provides a wider field of view. Okay, what type of mirrors are generally used to make such mirrors? So obviously so you have to remember that it can look for a wider region, but the after reflection it falls, it has a very small you can check the entire area using a small mirror. So that's what you have to remember, and it's a virtual image. Obviously you cannot check real image in your naked eye, right. To observe real image you have to use a screen, but in this case you are seeing a virtual image, so you have to be careful about that as well. With the help of a ray diagram, describe the nature of the image formed by the type of mirror identified in A. So only normal case, let's see. Okay, it is definitely a convex mirror. Okay, convex mirror has a high field of view, so you can check a large area using a small mirror. That is why it is used in a rear view mirror of a car. It is used as a directional mirror for whenever it is placed in the corner of a narrow lane, right? Also it is used to spy on people who may be trying to steal inside a shopping mall, etc., right? So that's why, because it has a large area field of view, so you can check from a small person sitting in front of the mirror at a particular angle. They can see whatever you are doing in the shopping mall, but you will not be able to see him. So that is why it is used. Similarly, this is a mirror which is used to check what is underneath your car if you are visiting a very sensitive area. So convex mirror is definitely the answer, and convex mirror has only one type of image formation, that is when you place the object in front of the mirror, it forms a virtual and diminished image. So this is a virtual image. One more thing, while drawing this, be careful about few things. Whenever you are drawing any ray diagram, okay, you need to be careful about few things. So if it is a virtual, better to draw it using a dotted line, and you have to show the arrows. Okay, you have to show the arrows only on the left hand side. Right hand side is basically behind the mirror, so you don't need to show any arrows in here. I have seen students, they put the arrows here. Arrows means light is actually traveling there, but behind the mirror the light is not traveling, so there should not be any arrows on the behind the mirror side. And behind the mirror you have to draw it using dotted line. Now as you can see, if you put a scale to join A and C, C is the center of curvature, A is the top of the object. Okay, so what you have to do, you have to put the scale, and up to this point, whenever this is hitting the mirror, that point you have to draw a solid line, then you have to draw a dotted line behind the mirror. Similarly, you have to draw a parallel line parallel to the principal axis. Now after it reaches the mirror, okay, now you have to put your scale like this, and then from here up to this you have to draw using dotted line, and then you have to draw a solid line, and definitely you have to put arrows. All the arrows are very, very important. Okay, then you have to just mark the points, like all the points. A, B is the object, A dash, B dash is the image, right? So everything is marked in the diagram itself. Next question, let's move on. Ramya wants to measure the current flowing through the circuit shown below. Which among the 4 ammeters can she use for the same? Show the calculations. Okay, so here Ramya, what is the main objective? Ramya wants to measure the current, okay, flowing through the circuit shown below. So she wants to measure the current in the circuit, that is the main current. Okay, not in any individual component. Okay, now what is the among the 4 ammeters can be used? Now here what they have given is that we have one bulb of 8 ohm resistance, one normal resistance of 4 ohm, and one resistance of 2 ohm, a battery of 12 volt. So these are the things that is given. So what we have to do, first we have to calculate the total resistance of the circuit. Total resistance of the circuit. First, how to start it? To start, we have to use this part first. Okay, this part is in parallel combination, so we know how to find the 2 resistors connected in parallel. What is the shortcut formula? Shortcut formula for parallel is given by R1 R2 divided by R1 plus R2. Okay, maybe in their answers they have given it something else. Let's see. So 8 and 4 are in parallel. So 8 and 4 are in parallel. So it will be 3. So it will be 8 by 3 ohm. Right? Am I making any mistake? No. So 8 by 3 ohm is the parallel resistance of this, and after that this 2 ohm is in the series with it. So total resistance will be 8 by 3 plus 2, that is 14 by 3. So 14 by 3 is the equivalent resistance. Now we just need to divide it by 12, so to find the current. So current will be 12 divided by 14 by 3, so which will be equals to 6 by 7, that is 18 by 7, which is approximately 2 point something, right? So more than 2, less than 3. More than 2, less than 3 should be your range. That is in ampere, not in milliampere. Also definitely you want to use the this one. Okay, why this one? Because if you are using 1 ampere, obviously milliampere is not possible. All the this one is in ampere, right? We'll see that in a detail again. So this one is also not possible. This is also in milliampere. Now this one in ampere, but it can measure only up to 1 ampere, right? Our value is around 2 point something, right? If it was 21, then it would have been 3. It is 18, that means it is 2.5, right? So it will be more than 1 ampere, so it is also not possible. So you want to measure some current which is approximately 2.5. Now 2.5 can only be measured when it is between 0 and 10 ampere. So definitely we will use this ammeter, right? Let's move on. Let's see the answer. So from Ohm's law, V is equal to IR, I is equal to V by R, given V is equal to 12 volt, R1 is 2 ohm, R2 is 8 ohm and R3 is 4 ohm. Therefore, the net resistance R1 is equal to, they have used the direct method, okay, and they have calculated some value 4.66 ohm, and they have calculated the current. As I said, it is 2.58 ampere. So I have approximated the answer without using calculators. They have found it slightly better than me using a calculator. Okay, so 2.58 ampere. If you do this calculation up to this much, you get 1 mark. Definitely 2 mark question, so there will be some division of marks. So if you do this calculation, then you will get 1 mark. And she can use the ammeter S to measure the current in the circuit. That is 0.5 mark. Why S? Because the range is between 0 to 10 ampere, so only S can measure the required current. Everything else is less. Okay, so this is basically the correct answer. For that you get another 0.5 marks. Okay, now remember, even though I don't think this kind of question will come, that option that I am going to talk about will come in your exam. So if they give you 2 ammeters, one is say 0 to 10, another is say 0 to 5, same question, then you want to use this one, because this one will be more accurate compared to 0 to 10 ampere. Okay, so because the value is between 0 to 5 and this is the smallest difference that is possible, we will always choose the smallest range as much as possible. In case they give you 0 to 3 ampere, you will choose 0 to 3 ampere over anything else. Why? Because your current is more or less 2.58, you know that, right? So you want to use some ampere which is between that range, right? And now there is a device called multimeter where you can switch the ranges. Okay, based on your sensitivity and requirement, you can change it to milliampere, you can change it to ampere, you can change the range to 10 ampere, you can change it to 1 ampere. Okay, so that is how you can change the range and your sensitivity. So this is one of the way to do that. Now as I said, if options were given which is closer to the maximum limit, we will choose that one instead of choosing the higher range. Okay, remember that. Now question number 25, this is also a question number 25, but this is an OR question. So let's see. An helical coil whose length is greater than its diameter is connected to a battery as shown. So there is a helical coil. Okay, this is a coil like a solenoid. Okay, diameter is connected, length is greater than its diameter, even though here it seems that the diameter is too long, but its length is more than its diameter. Okay, now how does the magnetic field at the point P compare to the magnetic field at point Q? Justify your answer. State one way in which the strength of the magnetic field inside the current carrying helical coil can be changed. Okay, so there are two part of the question. First, what is the relationship between them? Now if you see, it is equidistant from the coil axis of the coil. It is both points are almost equidistant, right? So equidistant means they will have the same magnetic field. And how what to do? There are few ways to do that. You can increase the number of turns, you can increase the current. If in this case I think battery and number of turns are both fixed, so what you can do, you can add a core, a soft iron core inside the coil to increase its strength. Okay, that is the answer that is they are looking for this question. Let's see the answer. So magnetic field at P and Q is the same because the magnetic field lines inside the helical coil of the wire, which behaves like a solenoid, is uniform in form of parallel straight lines. Accept any other valid another answer. So valid answer, that means the points P and Q are equidistant from the axis of the coil. That is more important, and then this comes handy. Okay, if you are adding this along with the fact that P and Q are equidistant. If P and Q are not equidistant, suppose we have a coil like this. Okay, inside the it is constant, but if the P is here and if my Q is here, what will be the magnetic field? There will be difference between P and Q, definitely. They are not equidistant, but if P, Q and say R, now P and R are equidistant from that axis. So definitely P and R will have the equal magnetic field, but definitely Q will not have the same magnetic field, even though the magnetic field inside the coil is constant. So in my opinion, this is incomplete explanation. You have to mention that they are equidistant from the axis of the coil. If they were inside the coil, if they are inside the coil, then it is a different question. I think I made a mistake. Yes. So one thing I made a mistake here. So here they have said this is P and this is Q, not this and this. So that was my mistake. So P and Q are inside the coil, so it does not matter where they are located, how they are located. They are located here or here. So suppose they give you this is P, this is Q. Okay, so they have given it like this, then it would have been better. So these arrows are missing. Okay, so this is P, this is Q. In this case also, P and Q, the magnetic field would be constant because inside the coil, the magnetic field is constant, uniform. Okay, now we have 1 mark for any of the following: increasing, decreasing the number of turn of the coil, increasing, decreasing the current through the coil, and one more point that I said, increasing, adding a material like soft iron in the core. Okay, now why this is important? Because suppose the coil is already fixed, right? Coil is fixed, the battery is fixed. How can you change the current? How can you increase the number of turns? It is already fixed. So in that case, only one way to change the magnetic field, by inserting an iron core. That is possible. That is because you are doing it from the outside, right? Now let's move on to the 3 marker question. Absolute refractive indices of two media P and Q are 1.33 Np and 2.52 Nq respectively. The speed of light in medium P is 2 into 10 to the power 8 meter per second. What would be the speed of light in medium Q? Vq. If the angle of incidence for ray of light traveling from medium P to Q is 0 degree, then what will be the path of light in the medium Q? So let's see, this is a numerical question. So speed of light in vacuum divided by speed of light in medium P. So Np is basically speed of light in vacuum. Np is basically C by Vp, and Nq is basically C by Vq, right? Therefore NP by NQ is VQ by VP. Now NP and NQ's values are given, and VP's values is also given, so you can easily calculate VQ, which will be 1.056 into 10 to the power of 8 meter per second. Okay, 1 mark for calculation and arriving at the correct answer. Okay, so 1 mark you get, 0.5 mark you get by writing these formulas. Okay, you can write it like this also, and 0.1 mark you get for this part, and part B is another 1.5. The ray will travel undeviated through the medium Q except any other valid answer. Okay, so because it's a normal incidence, 0 degree angle of incidence means it is a normal incidence, the light is falling along the normal. So in that case, what is happening here is the ray of light will travel undeviated because it is falling along the normal. Simple as that. It is falling along the normal. 0 degree incidence means 0 degree angle of incidence means it is falling along the normal. Okay, so that the angle is 0 degree. Okay, so in that case it will travel undeviated. Okay, 1 mark for that. I don't know what is this. This is I think wrong. Now next question. Kaveri conducted an experiment to study the energy efficiency of different bulbs. Okay, so she is doing some experiment with bulbs. She connected a bulb A having a resistance of 100 ohms to a 240 volt power supply in a laboratory. Okay, how much energy will be consumed by the bulb if it is kept on for 4 hours each day for a week? Okay, so we have to find the power consumed. Okay, express your answer in kilojoules. Okay, express your answers in kilojoules. Kaveri connects another similar bulb B in series with bulb A and connects the combination to a 240 volt supply. Will there be any change in the brightness with which bulb A glows? Now explain mathematically. So mathematically very important. Part B also we need to explain mathematically. So for part 1 we have to calculate the power. What is the formula for power? Normal formula for power I told you. Power is Vodafone Idea. Okay, so P is equal to VI. So V is given 240 volt, resistance is given 100 ohm. So from here VI and I is basically, what is I? I is equal to V by R, right? So it will be V square by R. So any bulb is given with the power rating, you can calculate the power consumed by it. So 240 volt whole square divided by 100. Okay, so it will be 24 into 24, whatever it is. Okay, we'll see, 596 I think. So what is the answer? 576, sorry. So if you calculate the power, V is given by 240 volt, R is 100 ohm, so power is V square by R, so it will be 240 whole square divided by 100, that is 576 watt. Okay, that for this calculation you get 0.5 marks. Okay, energy consumed by the bulb is given by A is equal to power into time, that is energy. Energy is power into time. Now how long it is running? It is running for 4 hours for 7 days. 4 hours for 7 days, and 1 hour is 60 minutes, 1 minute is 60 seconds. That is the international unit for time, right? You have to convert it into seconds. So now you calculate, you use mathematical calculations, and you find that it is 58060.8 kilojoules. So this is a huge number. Okay, marks will to be awarded if the student use any other method to arrive at the correct answer. This is the correct answer, obviously. There is no other method. You have to do the calculation, multiplication, and find the value. When the bulbs A and B are connected in series, okay, what is the net resistance? Net resistance will be, so in the second case actually interesting. We generally say that bulbs or any components, they has to be connected in parallel so that they both are getting the same voltage. Now in this case what they are saying, they have two bulbs, okay, they have connected. So I write the bulb like this. It represents the filament as well as the B symbol represents the bulb. Okay, So two bulbs, if you connect them in series, both of them has 100 ohm resistance. Similar bulbs, this is bulb A, this is bulb B, and this is also 100 ohm. So basically in their core they are behaving like a resistance, right? So their resistance means total resistance will be just addition, so that is 200. Okay, so that's what we have done here, right? So here also we have done net resistance is 200 ohm. The total power consumed by bulb A when connected in series with bulb B is given by, now you have to show the power. So power consumed is 144 watts, and what was the normal power consumed by it? Normal power consumed by it was 576 watt. Now it is only 144 watt. So that means previously it was consuming more power. Now the power consumption is reduced. Okay, so power consumed by the bulb A without bulb B was 576 watt, and with the bulb connected in series, it is previously it was consuming 576 watt, now it is consuming only 144 watt. So definitely PA dash is less than PA. The brightness of the bulb A decreases when connected in series with bulb B, for that 1 mark. Okay, and to show this calculation you get 0.5 mark. Okay, similarly here also 0.5 mark, and by calculating the power you get another 0.5 mark. So total 3 mark. I think 0.5 mark is missing, but it should be somewhere, right? I think to calculate this part you get 0.5 mark, 0.5 mark, 0.5 mark, 1.5 marks, and 2.5 marks. I think here it should be 1 mark. It should be 1 mark. Okay, so 1 mark, 1.5 mark, and here also 1.5 mark. Okay, so calculation has to be shown to get the full marks. Be careful about that. If you just answer it, you will not, maybe you will not get any marks. Without this calculation, this answer does not have any marks. So maybe based on the teacher who is checking the paper, he might say, okay, he has not done the calculation, he might have copied it from somewhere, so I will not give him marks. Okay, now this is another question. Vijaya connects 3 bulbs P, Q and R in series with the battery. So a lot of question based on electricity, not so much on light and optics in this part. Vijaya connects 3 bulbs P, Q and R in series with the battery in 2 different ways using their identical conducting wires as shown below. She notices that in case 1 all 3 bulbs glow, but in case 2 only the bulb P and R continue to glow. What could be the reason for the bulb Q not to glow in the case 2? So let's see what is the case. So first, they are all connected in series. Okay, so and they have connected in battery, so bulb all the current is passing through all the bulbs, so the bulb is glowing. Now in this case, this arrangement, there is an arrangement between L and M. This arrangement is called short circuiting. So you may have heard that short circuiting happened, fire happens. You have also heard about short circuiting in the fuse part, right? What is short circuiting? Short circuiting means when you are connecting 2 points directly. So in our short circuiting, in our household circuit, short circuiting means it is happening between positive and neutral wires directly. If they get connected directly, then a huge amount of current will start flowing, and that might burn your systems and devices, right? So but in this case, what is happening is that these 2 ends are short circuited. So current started here, it reached this bulb, but instead of going to bulb Q, it took this path because this has low resistance, so it will follow this path and then it will come back here. Okay, so this is called short circuiting. Here these 2 ends are getting short circuited, so you will not get this bulb glowing. To resistance when connected. Now next is a question related to resistance. 2 resistances when connected in parallel gives a combined resistance of 10/3 ohm. When the same 2 resistors are connected in series, the combined resistance becomes 15 ohm. Calculate the individual resistance of each resistor. So this is a normal mathematical question, right? You have solved similar questions in mathematics as well. In that case you have to use, so for suppose one is x, another one is y, then xy by x plus y is equal to 10/3, and x plus y equals to 15. So you have to solve these two equations. So first you have to put this x plus y here. So xy equals to 10 by 13, 10 by 3 into 15, that is 50. Then you take x equals to 50 by y, you put it here, you get a equation, you solve it, you get the value of y. Okay, this is the mathematical way of solving it. We will solve again in our next part. So the current will flow through the additional wire that connects the point L and M, avoiding the bulb as it offers a path of least or lower resistance as compared to the bulb. So that is 1 mark. Okay. So as I said, because it is short circuiting the points L and M, current will pass directly through the wire because it is offering a low resistance, and that is why it will not, no current will pass through the bulb P, so it will not glow. Okay, sorry, bulb Q, so it will not glow because no current is flowing in this through this bulb. Okay, so this is the first part, 1 mark for that. Now next part is 3 by 10 is equal to 1 by R1 R2. So you get one value here, one value here. You put the value, as I said, you will get a quadratic equation. If you solve the quadratic equation, you get R1 is 10 ohm, R2 is 10 ohm, R1 is 5 ohm, or vice versa, any one is correct. So for this equation, for writing the equation, you get 1 mark. For finding the actual value, you get 1 more mark. So total 3 marks. Right. So in this problem, first question only gives you 1 mark, and this calculation you can use it using xy as well. If you are comfortable using xy, no problem. Only thing you have to declare it x. Let's say the first resistance is x, second resistance is y. Okay, then you can formulate the equations just like mathematics. If you are good in mathematics, maybe you are not super good in physics calculations, you can use mathematical knowledge to solve the question. Now 5 marker question, let's see. Savera passed a beam of white light through a series of equilateral prism as shown. What colors will be seen on the screen? Okay, so first beam of white light is passed. Because it is taken from the question paper, the text is not clear. It is beam of white light. It is getting passed through the glass prism, first glass prism. Okay, now then again there is a prism 2 and there is a prism 3 and there is a screen. What will happen? Okay, copy the diagram above and draw the beam entering prism 1 and emerging from prism 3 and falling on the screen. Name all the processes that takes place when the beam of the light enters the prism 1 and emerges from prism 3. So very interesting question. So definitely first prism, the light will be dispersed into 7 constituent colors. After emerging, it will get converged again. Okay, reconstruction, then again it will emerge as a single color, white light, then again it will emerge all 7 colors and you will get some light, right? This is how it works. So you will get red here, violet here. So you will get the Vibgyor down from down to upwards, right? So let's see the answer. First we see the answer to this, then we will see the OR question. Okay, so as you can see that first the ray of light passes through the prism 1, disperse into all the colors, then second prism recombines them, but third prism again separate them again and you get all the colors in the screen. So Vibgyor 1 mark, violet, indigo, blue, green, yellow, orange, red. So all the colors that you get is Vibgyor. Okay, you have to mention the names. Okay, 1 mark each for drawing the incident and emerging rays in the 3 prisms respectively. So for incident ray you get 1 mark, for refracted ray you get 1 mark for each prism. Okay, so 2 marks. Okay, so incident and emergent ray you get 1 mark for this prism, 1 mark for this prism, 1 mark for this prism. So that is 3 marks and 1 mark here, 4 marks. And what is happening? Dispersion is happening. This is dispersion. Okay, and also because it is a prism, the light is changing one place to another, definitely refraction is also happening. So this is air, right? So light is traveling from air to glass. So air to glass means definitely refraction is happening. That's why the lights are bending, right? So refraction is happening, and recombination is also happening in this case. But recombination we generally do not name it separately. It is not a special process. It's just a reverse dispersion. So that's why you do not need to mention about that. Now let's see the OR question 36. Okay, Rupal suffers from myopia. Where would the image from her inner eye? Where would the image form in her inner eye? So myopia means definitely the lens is forming the image in front of the retina, right? So the image is getting formed in front of the retina. That's why it is called myopia. Okay. Hypermetropia is when it is forming behind the retina for closer objects. Myopia is when the image is getting formed in front of the retina, okay, in case of distant objects. So hypermetropia and myopia, they are different, right? Rupal underwent a cataract surgery and her eye lens was replaced with an artificial lens with a fixed focal length made of plastic material silicone. State one likely visual disadvantage that Rupal is likely to experience as compared to person who has normal eyesight. So if your eye was replaced using a focal length of constant focal length, then definitely your eye will not be able to accommodate distant and closer objects. Okay, at a certain distance you will be able to see it clearly, but your eyes will not be able to accommodate them correctly. So definitely you will lose the accommodation of the eye. That is using same eye you cannot see distant object and closer objects. Okay. Identify the parts of the eye labeled in the diagram for the description of the given below by writing the labels as your answer. So you have to label all these parts. Okay, ciliary muscles, then cornea, okay, retina. First of all, they have to labels as your answer. Number one, it helps changing the focal length of the lens. So that is ciliary muscles. R is the ciliary muscles. You have to identify. Okay. It causes most of the refraction of the light emerging, entering the eye. So that is the eye lens. Okay, this is the eye lens. It controls the amount of light entering the eye, that is pupil. This is the pupil. P is the pupil. Okay. It acts as a screen which the image is formed, that is your retina, right? Nothing about this protective layer. Let's see the answer. In front of the retina, 1 mark. If you answer just in front of the retina, it's 1 mark. Okay. Concave lens, 1 mark. The person would not have the power of accommodation, 1 mark. Okay. 0.5 marks each for the following. So R, Q, A, P, S. I already said R, P, Q, S. You have to mention correctly. I made one mistake. R is the ciliary muscle. Obviously, R is the ciliary muscle. It causes most of the refraction of entering the eye. That is, okay, they have somehow mentioning this one is responsible for refraction. I think this is incorrect. Okay, this is not responsible for refraction. It controls the amount of light that is entering. Okay, so that is the main thing. This is the part which is refracting. That is the eye lens. So in my opinion, it will be RT PS. Okay, there is a slight mistake in the model answer. It will not be Q. Okay, P will go here and RT, sorry, no, it will be Q. It will be Q T. Okay, RT PS, that should be the answer. Okay, now section E, 4 mark question. Again another question from the circuit diagram. 4 resistors of voltmeter and a battery are connected in a circuit as shown below. What is the net resistance in the circuit? How much potential difference will the voltmeter connected across the resistor R4 measures? Okay, so even though it's a case based question, this question is more straightforward than a 5-mark question. 5-mark question there was some case, some explanation. Even 3-mark question was also some case based question. Here there is no case, they have just given the straightforward problem. Okay, 4 resistors, a voltmeter and a battery are connected in the circuit as shown below. So 4 resistors, 1, 2, 3, 4 are connected. There is a voltmeter connected across this resistor, okay, R4. What is the net resistance of the circuit? So here it is 15 ohm. Maybe it is not clearly visible. This is 30 ohm. And this is again another 15 ohm. And this is also 15 ohm. Okay, so this is how it is given. So first of all, these two are connected in parallel. So first we will calculate this part. Okay, say R parallel. So R parallel is, as I said, 30 into 15 divided by 30 plus 15, that is 45. 30 plus 15 is 45. So I am just writing it directly. Okay. 3 15s are 45, 3 10s are 30, so it is 10 ohm. Okay, now all these are connected in series. So they are connected in series means total resistance is 15 plus 10 plus 15, that is 30 plus 10, that is 40 ohm. So 40 ohm is the total resistance, net resistance, right? And the potential applied is 20 volt. So current will be V by R, that is 20 by 40, that is 0.5 ampere. Okay, now what is the question? What is the net resistance? Net resistance is 40 ohm. How much potential difference will the voltmeter connected across the resistor R4 measure? Okay, so resistors R4 will measure a voltage. The current in this circuit is 0.5 ampere. So this one will measure 0.5 into 15, that is 7.5 volt. Okay, so 7.5 volt will be the answer. Now there is our question. What is the power dissipated by resistor R1? So power dissipated, again current is 0.5. So power dissipated is P is equal to V square by R, or V into I, or I square into R. Okay, in this case we will use I square into R. Okay, V is not known yet. So I square into R. In my opinion, don't attempt the OR question. Okay, OR questions generally are slightly difficult in most cases. So I is 0.5 whole square and R is 15. We will see that in a clear format. Okay, we will just trying to understand the question so that if you have any doubt, that can be cleared. Okay, if R3 is removed, will the net current in the circuit increase or decrease or remain the same? So if you remove this 15 ohm, okay, if you remove this 15 ohm, then the total resistance will be 15 plus 30 plus 15, that is 60 ohm. So definitely it will increase. Okay, justify your answer. This is a parallel combination. If you remove one of the resistance from the parallel combination, then the net resistance will definitely increase, right? So let's see, the net resistance is given by 40 ohm. We have already calculated that. Voltage drop across R4 is net current into R4, that is 20 by 40, that is 0.5 ampere. So you get 0.5 marks for that, 0.5 marks for writing the equations. So in my opinion, you can calculate this part separately. Okay, we have done like that. So 10 ohm coming from there, then you just need to add these two parts. Okay, so for that also you will get 0.5 marks for calculating this parallel combination, and 0.5 marks for calculating the total resistance, right? For calculating the current you get 1 mark. Power drop across resistance R4 is basically 0.5 into 15, that is 7.5 volt. You get 1 more mark. So total you get 2.5 marks, and I think the OR was okay, OR was only for this question, okay, only for B, part B there is a OR question, C is compulsory, okay. So power dissipated by resistance R1 is given by V by R. So again you have to calculate the current, and then from the current you have to calculate the power V I square R, that is 3.75 watt, okay. Now net current will decrease obviously because resistance is increasing, because R3 is connected in parallel, and removing it will increase the net resistance in the circuit, thereby reducing the net current. So this, for these two parts you get 0.5. So total marks is 4 in this question. So if you have any doubt, don't forget to mention that in the comment below. I will be back with sample paper 5. Till then, bye.